Welcome to another video. In this lesson, we are going to talk about medical imaging. So in this lesson, you will know how does X-ray, what is X-ray, what is CT or computed tomography, what is MRI or magnetic resonance imaging, what is PET or the positron emission tomography, and the ultrasonography. So let's not waste our time, let's get right into it. First of all, we have X-ray. So here is an example of the X-ray of a hand. So X-ray, so this is the hand, and this is the bones of our hand. So the way to capture this image, it projects high electromagnetic radiation against the area of a body with a metal plate behind it. So there's kind of some plate, a metal plate behind this hand. Then the high energy electromagnetic radiation is is then got to, and it captured this image. So as you can see, this image are slightly blocked by the soft tissue. So this is the soft tissue. The hand. You can even see the textures of the palm here, some kind of textures, and some of the radiation are then fully blocked by this bone or your teeth, right? Which results in this kind of white shadow. So high energy electromagnetic radiation allows the internal structures of the body, mostly bones, to be seen in X-rays like these. Let's talk about different medical images. Oops. So here, so first, this is a CT scan, or what we call the computed tomography. So in the picture, you can see this is the CT scan of a head in successive transverse sections. So transverse meaning horizontally. This is horizontally. So this is our head. So this is actually, oh I can't zoom. Okay, so this is our head, and our head are then sliced into different sections, which cause these to be seen. So in a CT scan, the patient lies on a platform, while the computerized eggshell tomography generates multiple X-rays as it rotates around the patient. So these X-rays or slices are then assembled in a very detailed image, and soft tissue masses can now be measured using the CT scan to the millimeter, with the drawback of large radiation exposure. Next one is the MRI machine. The MRI machine is this. So the MRI machine creates some kind of magnetic field, and it scans patients using electromagnets and radio waves. And the scan does not really expose the patients into large doses of radiation, unlike the CT scan. But however, there's a drawback to this. very, very loud, and the tube might trigger claustrophobia. So you, the patient, going to lay down here. You go inside, and this MRI machine will go spin, but it doesn't really spin. The inside of this will spin, and which what makes creates loud noises, and you know it might be really traumatic, so to some people, and but yeah, so that's the purpose of the MRI machine. So I have a friend of mine. He uses, he got into the MRI machine or the magnetic resonance image, and um, mm, and he doesn't, she doesn't really know because I think she has symptoms. So the doctor told her to take an MRI, and unfortunately, she the MRI machine detected a brain tumor on her, which is kind of sad to know. But yeah, he got, she got, and now at least it got, um, it got really, it got really, it got really, no, it got really, it was still very small, so it's nice to know that he got informed really, really early, as if he got into that MRI machine really late, because it might actually cause troubles. So here, that's why I'm stuttering, because I'm searching for an image result of what an MRI machine looks like. So this is um, a result of what result of like. So as you can see, the different parts of the brain. As you can see here, it mostly focuses on the brain. So as you can see here, most of these are brain scans. So yeah, as you can see, the different parts of the brain. So you can really see what has damage or what is okay in your brain. So yeah, okay, enough, enough telling some things. Next we have um, the the PET, or the positron electromagnetic, oh sorry, the positron electromagnetic tomography. So in the PET, or the positron emission, it's not electron, it's positron emission tomography, uses a short-lived radioactive contrast that will travel areas with high metabolic activity, such as cancer. So as you can see here, these are images of active blood flow of the body. So it can really see what the body is doing, what it is doing at that point in time. So this is what you can see on a PT. So the isotope will break down, which causes the photons to be released and be detected by the scanners, which results in this kind of image. So remember that PET shows us the activity within our bodies, which are stated in our first lesson, that the activities of the body are caused by physiology, the physics of structures, the study of function of structures, while the CT scan and the MRI and the X-ray are mostly talks about the anatomy part, which can see the body, the structure, the form or the body of structure. Okay, next, next one, the last one. You're probably familiar with these. This is what we call the ultrasound or ultrasonography. Ultra ultrasound technology. So it uses a frequency of sound waves. It uses sound waves instead of dangerous radioactive waves. So this is the least invasive imaging technique, and ultrasound is commonly used to monitor pregnancy. So by the sound of it, ultrasound, it uses sound waves to generate an image. So this is not really deadly. So since we have ended chapter, let's review the lesson objectives or the chapter objectives in this. So we know what is anatomy and physiology, and we identified the several branches of each. Then we describe the structure of the body for the simplest to most complex. So that's the body organization from molecule level to organismal level. We talk about that in section 1.2. Next, we identify the functional characteristics of human life. So we talk about that in section 3. So I recommend watching it. Then we identify the 4 requirements for human survival. What does the human survival need? We talk about that in section 1.4. And we also defined homeostasis and why homeostasis is important. We also talk, this is a very long topic, talk about anatomical terminology, and we identify the body regions, the different directions, the structures, the quadrants, the abdominal quadrants. So I recommend watching that. And we also compare and contrast at least 4, but we got to regards to 5, which is in this video, medical images and what are their functions and what do they use in imaging. So that's it for section 1.7, and I'll see you in chapter 2, and I'm excited to see all of you in there. Thank you for watching.